So just with any function that we've learned, like a quadratic function or x squared, we learned how to graph them first. That was all of chapter 2. And then we learned how to do operations with them. And that's what we're doing in 7.3. We talked about inverses, and now we're going to look at rational functions. And we learned how to graph them in the last section. You just quizzed on that. And now we're going to learn operations like simplify, multiply, divide, add, subtract, and then we'll get to solving. So first, copy down the definitions into your journal, or if you'd like to, at the top of page 6 of your notes. Journal page 202, copy down the definitions for rational expression and simplified form of a rational expression. So in this video, we're going to simplify rational expressions, and we will divide. First, let's look at simplifying. If you think about simplifying a fraction like this example here, 15 can be broken down to 3 times 5, 65 to 13 times 5. So then we can divide out the 5s, and our simplified is 3 over 13. So now we're going to be looking at expressions like 4x plus 12 and x squared plus 6x plus 9. What we can do is factor the numerator, factor the denominator, cross out common factors, and then this would be our simplified answer. So let's try that in an example. So simplifying is basically 2 steps. I know it's written in print and then I just wrote it here. You want to factor the numerator and denominator completely and then divide out any common factors. So let's try that in example 1. The numerator is an easy trinomial that can be factored into x minus 6, x plus 2. The denominator is a difference of squares that can be factored into x minus 2 and x plus 2. You then want to divide out any common factors. So you can see we have an x plus 2 on the top and the bottom that cross out, and then you're going to write your final answer, which will be x minus 6 over x minus 2. This is our final answer. You cannot cross out the x's and then be left with negative 6 over negative 2, which is 3. That would be a big no-no, like if you try and cross out those. No. Next, we're going to multiply rational expressions, which is very easy. In fact, we multiply before we add and subtract because it's very easy. Multiplying is very similar to simplifying. You can see here we have a monomial example. We multiply it across, and then you simplify this like you would any other expression. Same thing goes when you have to factor first. Just factor everything and then cross it out. So let's look at the examples. So in example 2, just like we saw in the journal, go ahead and multiply across first. 8 times 7 is 56. X cubed times x to the 4th, you'll add the exponents and get x to the 7th. And y to the 1st times y cubed, again we'll add the exponents. Now multiply the denominators. You'll get 8xy cubed. Now, when you have a monomial over a monomial, notice there are no pluses or minuses. You can just simply divide each. 56 divided by 8 is 7. X to the 7th divided by x is x to the 6th. Y to the 4th divided by y cubed is y. How did I get that? You subtract exponents when you divide. Before you simplify, you should also state the domain. And the domain is all numbers except what would make the denominator 0. And we have both x and y in the denominator, so both x and y are not allowed to equal 0. Now let's look at example 3. So the first thing you want to do is factor everywhere. So in this first numerator, I can take out a 3x. I'm then left with 1 minus x. The denominator is an easy trinomial. X plus 5, x minus 1. The next numerator, another easy trinomial, x plus 5, x minus 4. And then the denominator cannot be factored. Before we start canceling things out, let's write the domain. And domain is anything in the denominator that would make it 0. So x cannot equal, from this fraction, just take the opposite. If it's x plus 5, x can't equal negative 5. The next fraction, x can't equal positive 1, and an x with no plus or minus, it can't equal 0. So now let's start crossing out. I have an x plus 5 on the top and 1 on the bottom over here that will cancel. I have a 3x that will cancel here and here. These two do not cancel right now, but there's a little trick. 1 minus x, if you were to switch the order, is negative x plus 1. Now they're still not the same, but if you factor out a negative 1, it then becomes x minus 1. So your trick here is you can rewrite this as x minus 1 if you take a negative out. So now the two x minus 1s will cancel, and I'm left with a negative 1 on top and an x minus 4 over here. So negative 1 on top along with an x minus 4 on top. So that's my final answer. We don't need to write the 1 actually. In the final example, again we're multiplying. The second polynomial isn't really a rational function because it's not a fraction, but we can easily make it a fraction by just placing it over 1. So now let's do those same steps as we did in example 3. First, let's factor everywhere. This first numerator does not factor, so it's x plus 2. This denominator is a difference of cubes. So remember we did that factor worksheet the other day. Difference of cubes is you cube root each, then you square, times them together, and then square. And your signs follow SOAP. The next numerator, there's no factors of 9 that add to 3, so it's not factorable, so I'm just going to recopy it. Now, before I start canceling, I should state the domain. That's going to be part of your answer. So it's all real except x can't equal 3, and since this one can't factor, that's it. X can't equal 3. So let's cross off any common factors. Notice these two are the same, so this will divide out with this one. They divide out, and our answer is x plus 2 over x minus 3. And remember, you cannot cross off the x's here and get an answer of negative 2/3. That would not make any sense. Please remember to have this written into your notes. If you write it on separate paper because you don't have your packet, either write it in later or staple it to your packet. Please write down any questions you might have. Thank you, and I hope you had a nice break.